Photographic Composition, Lecture 2, The Camera and Lens, Part 2. We had talked a bit about how the lens and camera work. Now we're going to talk a bit about the camera shutter. The shutter basically controls the length of time that the sensor or film is exposed to light. A faster shutter lets in less light, but is capable of stopping action. Longer shutter speeds let in more light, however they do not freeze action well, usually requiring the use of a tripod. And DSLR cameras use the focal plane type of shutter as opposed to the leaf shutter found in some medium format cameras. And again, the technology is not something you really need to know about except for how what you control changes the way your images look. And here are just a couple of examples of how, first of all, what the shutter looks like, the shutter mechanism, and how changing shutter speed without altering the aperture, which we will get to soon, will look. So at a 500th of a second, you end up with a much darker image than you do at a 15th of a second. And this might be useful to you. This is a fast shutter speed. You can see that not only are the buoys frozen in space and the ball, but also the drops of water. So if you're interested in covering action and you want to make sure that you see moving objects in detail, use a fast shutter speed. Here's another example. And here's an example of panning the camera while having a relatively slow shutter speed, which means that everything that is moving, with the exception of the subject, is blurred. And if you want to convey speed or action and are less concerned with detail in the subject, slow shutter speed can be the way to go. If you have the camera on a tripod, then you have the option of shooting under very low light levels, like the image by Versailles taken from Notre Dame and overlooking the city of Paris. Of course, with much more sensitive DSLRs that we have at our disposal now, this scene or something like it would be much easier to create, although it would be very different. Again, a slow shutter speed. Objects that are moving, blurred if the camera is fixed, and objects that are not moving, stay clear. All right, now we're going to look at lenses. And lenses, as we've already discussed, are very much like the human eye, although a kind of crude representation. As good as lenses have become, they're still crude in comparison to the human eye, which is an amazing instrument. It has a lens at the front, a aperture that emulates the pupil, and the film plane or the retina onto which scenes are projected at the back of the eye, at the back of the camera. They come in wide angle and telephoto, depending on how you want to record whatever is happening in front of the camera. Wide angle tends to distort considerably, and objects that are nearby look huge, objects in the distance look small. as opposed to a telephoto, which tends to compress space and will bring objects that appear to be that are far away up close. The depth of field of a wide-angle lens is much greater than that of a telephoto lens, which can be used, a condition that can be used creatively. This gives you an idea of the relative angles of various lenses. As you can see, a 16 millimeter lens is very wide, and I can't even read the longest focal length that they have recorded here, but it's at least 135. It's probably close to 200 millimeters. And here's a variety of lenses. These are zoom lenses, and they allow for a variety of focal lengths. They tend to distort a little bit more than the prime lenses, which are fixed at specific focal lengths, but have the advantage of allowing you to go from wide angle to telephoto without removing a lens. And here's an instance of a image that has been made while a zoom lens has been adjusted from wide to telephoto. And this is typical of the view one gets with a wide-angle lens. As you can see, there is quite a bit of perspective distortion because the lens has been tilted. And the condition that we refer to in architectural photography is keystoning, where you see that as you look down on objects that otherwise would have parallel verticals, those parallels have been distorted. Wide-angle lenses, as I've mentioned, tend to distort considerably. Objects that are close to the camera can appear huge, and in fact large enough that the rest of this person is completely obscured by their feet. And here's the opposite condition. This was taken with a telephoto lens, which makes these row houses look like they're absolutely built right on top of each other. They're close, but not as close as this image would suggest. That's a condition of telephoto lens. Telephoto lens or a macro lens also allows you to focus on very small objects, sometimes with the aid of additional adapter lenses. But we can see very small objects in great detail. And this just gives you an idea. Now we're talking about depth of field or depth of focus. The wider the aperture in the camera, the shallower the depth of field. And the smaller the aperture, the greater the depth of field. In plain terms, if all you want to do is record your subject clearly and not worry about the background or the foreground being in focus, then shallow depth of field, a wide aperture is what you want. If you want everything that you can see in focus, then a small aperture is what you need. This just gives you an idea of what those apertures actually look like in a lens. And here's the effect, where with the aperture wide open, a very small area is actually in focus. And in the middle illustration, more of the birds are now in focus. And at f/22, virtually everything is in focus. This is very extreme selective focus using shallow depth of field. So this is probably taken with a lens that's absolutely wide open, very small, very large aperture, and the focus is absolutely on the ball. Same thing is true here, although this is much easier to pull off because this guy isn't actually moving. Some photographers are really intent on getting as much detail in their images as they possibly can. This was an image made by Stephen Shore in the early 70s, and he uses an 8x10 camera. It's 8x10 inches. It's the size of the film, and would stop it down as virtually as far as it would go, f32 at least, maybe even 45 or 64. And as a result, all the objects in the foreground are in focus, and the mountains in the background are in focus. Everything's in focus except for a couple of objects that are moving, specifically the orange Carmen Gia in the lower left-hand corner. But virtually everything else has been stopped in great detail.